Okay, so we're going to start getting into trigonometry now. This stuff can get a little bit tricky, but when we're dealing with right triangles, we can use trigonometry to find, if we're given enough information, we can use trig functions to find everything else that's missing, which is really nice. So, what is trigonometry? We'll start there. Trigonometry is the study of triangle measurement. The study of triangle measurement. There are three different trig functions. So each acute angle of a right triangle has the following trigonometric ratios. So we can look at the first one being sine, and that is the ratio of the leg opposite to the angle to the hypotenuse. So if I'm looking at angle A here, the sine of angle A is the ratio of the leg opposite, so the one directly across from it, to the angle of the hypotenuse. Now the hypotenuse, remember, is the same no matter what angle you're looking at. The hypotenuse is always the hypotenuse. There are two legs, however, and so when you're dealing with sine, it's the leg opposite the angle. So the sine of angle A in this case is side A over the hypotenuse C. Okay. Then if I want to look at angle B here, the sine of angle B is the side opposite it, which in this case is side B, over the hypotenuse as well. So B over C. Okay. So then we have our cosine function, and that's the ratio of the leg adjacent to the angle to the hypotenuse. So now we're looking at the leg adjacent. Now when I'm looking at angle A, the leg adjacent, remember adjacent means next to. So it's the adjacent connecting the angle to the hypotenuse. It's not, even though the hypotenuse is adjacent, it's not the hypotenuse because the hypotenuse is the hypotenuse. So in this case, side B is adjacent to angle A. So it is side B over the hypotenuse. Then if we're looking at side B or angle B, the side adjacent to it would be side A. So the cosine of angle B is the adjacent side A over the hypotenuse C. And then we have tangent, which is the ratio of the leg opposite to the leg adjacent to the angle. So we're not dealing with hypotenuse when we deal with tangent. The hypotenuse is irrelevant. So we have to look again for our opposite and our adjacent sides. So the tangent of angle A is going to be leg A over leg B. And then for angle B, again, the side opposite of angle B is side B over the adjacent, which is A in this case. So those are my trig ratios in reference to this triangle over here. Okay, sorry, I just wanted to make sure my microphone was on. So we have this cool trick that we know, or we can use, and it's kind of sounds like an Indian name of some sort, but it's what we call SOHCAHTOA. SOHCAHTOA, where SO represents the sine of an angle, which is equal to the opposite over the hypotenuse. Ka, which is the cosine, is equal to the adjacent over the hypotenuse. And TOA, which is the tangent, equal to the opposite over the adjacent. So, SOH, CAH, TOA. SOHCA, TOA. Remember this. It's very important to remember. Okay. So let's look at number 1. Let's try and find these trigonometric functions in simplest form. So I want to look at the sine of, or I want to find the trig function ratios of angle A. Okay. I like to go through and I like to label which side is which. So this side 12 here, this is my side adjacent. This one here is my opposite, and this, of course, is my hypotenuse. Okay. So sine, that's SOA, that is SOH, so it's the opposite over the hypotenuse. So in this case, 5 over 13. Then I gotta look at my cosine, KAH, so 12 over 13, my adjacent over my hypotenuse, and then my TOA, my opposite, which is 5, over my adjacent, which is 12. Then I have to look through and see, can I simplify these, or are they already in simplest form? Do that. In this case, these 3 are already simplified, so I can't simplify them any further. And that's all when you're trying to write the trigonometric ratios of an angle. So go ahead and try to do the trig functions of angle C. This one right here. I'm going to go ahead and have you guys do 2 and 3. Look at, notice how 2 and 3, I'm not given all 3 sides, but I am given 2. Remember, we can use that cool thing we know called the Pythagorean theorem, and to find that third side, though. So Pythagorean theorem, remember, is a squared plus b squared equals c squared. So 9 squared plus 12 squared equals x squared. So 81 plus 144 equals x squared. So 225 equals x squared. Then I have to take the square root of both of those. So x equals 15. That means this side here is 15. Okay. Then you use that now that you know all 3 sides, use that to find the trig functions for angle W and angle X. And then do 3 as well. On the back, this is where we get into the big stuff, the big trig stuff. So once again, you're going to need your calculators, and you have to make sure they're in degree mode. Can't stress that enough. If they are not, you're going to get all wrong answers here for each of these problems, and I'd hate for that to happen. So let's look at number 1. I have to look at what sides I'm given in reference to the angle that I'm given. I am given this angle here 28 degrees. I am also given the hypotenuse of this triangle and the side opposite. Even though it's just an x, that's still what I'm trying to find. That's what I'm given. I'm not given the adjacent, so I don't need to deal with that. That tells me I need to use my SO function, my sine. So I need to put my opposite over my hypotenuse. Oh, I can't write today. My hypotenuse. So that tells me the cosine of 28 is equal to my opposite, which is x, over my hypotenuse, which is 19. Now I use this and I use my basic algebra to solve for x. So I got to get x all by itself. I multiply both sides by 19. So leaving x equal to 19 times the cosine of 28. Why am I writing cosine? This is sine. I'm sorry, guys. I don't know what I'm doing here. The sine of 28. And this is where I use my calculator now. I put 19 times, and then I hit the sign button. In those parentheses, I put in 28, close the parentheses, and you should end up with an answer of 8.9 if your calculator is in the correct mode. If it is not in the correct mode, you will end up with, I believe, like 5.2. That's not it. Your calculator is not in the correct mode in that case. So make sure that it is in that degree mode. If you're having trouble getting it into that degree mode, send me a message, Google how to do it, ask a friend, something like that. Come in and see me in the morning. I can try and help you there. But it is so important that you have it in the correct mode. All right, so I'm going to skip number 3. I want to look at number 5. So, again, I have to look at what sides am I given. I am given my opposite and my hypotenuse. Oh, I'm given my again. So I'm going to be using my sine function again, which is my opposite over my hypotenuse. So that means the sine of 33 is equal to 15 over x. Now this one's a little bit different. I can't just multiply by 15 and keep going. That's not going to eliminate that 15 and leave x by itself. I have to multiply by x first. That's going to cancel it over here, leaving me with x times the sine of 33 is equal to 15. Now I can divide by the sine of 33 on both sides, canceling those, leave me with x equals 15 divided by sine of 33. And now I can put this in my calculator and find x. So in this case, x equals 27.5. If you got something different, check your math, check your calculator mode. Okay, so you have to look at what are you given. We can look at number 3 just to kind of set it up since we've done 2 sine functions. I think this one's different. Here's my angle I'm given, 21 degrees. I am given the adjacent side and the hypotenuse. That tells me I'm going to use my cosine function. And I'm going to set it up using my adjacent and my hypotenuse. So then I want to look at number 9. Again, word problems are not scary, guys. Don't get so scared. Alright, I'm going to draw my picture. I'm going to show my sweet art skills. Jake leaned a 12-foot ladder against his house. If the angle formed by the ladder and the ground is 68 degrees, how far from the base of the house did he place the ladder? Alright, I'm going to draw my house. And then I need to draw my ladder. Alright. So I am trying to find how far from the base of the house that ladder is sitting. It is a 12-foot ladder, so I know that's how long it is. And it forms an angle with the ground that is 68 degrees. So I am given my hypotenuse, and I'm trying to find my side adjacent. That tells me I'm going to use my function, my adjacent over my hypotenuse. So the cosine of 68, not 680, is equal to my adjacent side, x, over my hypotenuse, 12. I gotta multiply both sides by 12. x equals 12 times the cosine of 68. When I put that in my calculator, I type 12 times, I hit that cosine button, and then I put 68 in the parentheses. That should give me about 4.5. So the ladder is standing 4.5 feet away from the house. So when you're looking at number 10, draw a picture. Draw. Word problems are not scary if you draw the picture. Think about what it's giving you. Think about what it's asking you for. I want you to go ahead and finish 3, do 7, and then do all the evens. Also, don't forget to finish 1, 2, and then do 3 on the front. Come to class prepared with questions if you have them, ones you want to go over just to check your work, and then we'll work on the assignment. Come in and see me in the morning if you're having trouble with your calculator. If you're having trouble getting the final answer correct, at least get the problem set up all the way to this point or to this point without putting in the final math at least. And then that way I know at least you're getting it set up right. You're just having calculator problems. Okay, send me a message if you need help.